Welcome to the homework help video for homework 3. In this video, we'll work through completing the commuter statistics problem. The project we are going to complete in this video is designed to be very similar to your homework 3, but it is not the actual assignment you need to complete for your grade. This project completes the same types of tasks in the same order, but with a different data set than your actual assignment. You will not receive credit for completing the homework help project shown in this video. This homework help project uses Microsoft Access, which is only supported on Windows. If you have a Mac, to complete this project, you will need to follow the instructions in eCampus to use Azure Virtual Desktop to access a Windows computer. To start off, I've downloaded the instructions PDF and the provided data files for this assignment to my desktop. I'm going to extract the contents of the zip file so I can access the individual XML files that will import inside of it. I'm going to right-click on my data files.zip file here and go to extract all, and then I'll just click extract. That's going to create this new folder here. Inside of it, you'll find counties.xml and states.xml that will import in Access. Next, let's start up Microsoft Access and create a new database. I'm going to go to my Start menu. Now, in my case, I have Access pinned here at the top, but you might have to go look for it. Sometimes under the All section, depending on which version of Windows you're running, it might be under a Productivity section. You can find it there, or if worse comes to worse, you can always search for Access. Once Access starts, go ahead and click the option to create a new blank database. And it's going to ask you what you want to call your file and where you would like to place it. Click the little folder icon here and go and place your file someplace where you can find it easily. The desktop tends to be a good choice for that. And we want to name our file hwhelp3_CSP for commuter statistics problem. Underscore, and then we're going to type in our last name, underscore our first name. And then the extension for this as an Access database will be .accdb. And we can go ahead and click OK. And then we'll just click the Create button. And we'll get a new database here. And we can click to close out of Table 1 because we're not going to use that. Step 3 wants us to import the structure and data of the two XML files that were inside of that zip file that we downloaded. Here in Access, I'm going to go to the External Data ribbon. We'll go to New Data Source, from File, and then we'll choose XML file. I'm going to click Browse and go to where I put my files. So in my case, on the desktop. We'll go into the Data Files HH3 CSP folder. And we'll just do states.xml first, since that's the first one that's listed in the instructions. I'll click to select it, and then click Open. And then I'll go ahead and click OK. It's going to ask me what I want to bring in. The default option, structure and data, is what I want. So I'll click OK. And then I will click Close on this last step of the wizard. Then you can see we have the table brought in. And if I double click on it, I can see that I have a whole bunch of records already in it. We're going to repeat this process for the counties.xml file. So we'll go back to external data, new data source, from file, XML file. We'll browse again, and this time choose counties.xml. We'll tell it to open, and then click OK. We'll bring in structure and data again, so we'll just tell it OK, and then we'll click close. This file has a lot more records than the states one, because there's a record here for every county in the US. Excel is a bit different than the other Microsoft 365 applications like Word, Excel, and PowerPoint in that it will continuously save most of the changes that you make to your database. If you go and import tables like we did with counties and states, as soon as those are imported, they're automatically saved. You don't have to go and save the file. In fact, here, I actually can't even click the Save button because there's no changes to save. The same thing goes when you add, edit, or delete records in a table. As soon as you finish making that change, Access will automatically go and save that change to the database. One case where things are a little bit different is if you're creating a new table or editing the design of an existing table. There, your changes won't be committed to the file until you actually click Save. Let's see how that works now with step 4A, where we're going to create the regions table. To create the table, we'll go to the Create ribbon and click on Table Design. And the instructions give us two fields that we're going to need to put in this table. The first one will be region ABBRV, short for region abbreviation. Abbreviations are normally going to be text, and if we actually look at the table's data that we're going to enter in a coming step here, we'll see that the abbreviation is all text. So that means we really only have two data types that are going to apply here: short text or long text. Short text is designed for when we have no more than 255 characters. Long text is basically for where we have potentially the need for more than those 255 characters. So short text is the appropriate type for this field, and that's actually the default here. So we'll go ahead and take that. The other field that we're going to have here is called region name. And this one is also going to be text, and we'll go with short text for this type as well because it's also a fairly short number of characters that we'll have for this. Now, between these two fields, the instructions tell us that we need to choose an appropriate primary key for our table. Primary keys should be fields that are going to have unique values in, and both the abbreviation and the name are unique. So we want to look at the contents of what's in those fields and how they relate to potentially other tables that we might connect with. Abbreviation is shorter, and generally speaking, shorter tends to be better for primary keys. The thing that really seals it for us is if we go and take a look at the states table that we imported, we actually see there's a region abbreviation field in there. So that is going to be a field that we'll include in a relationship back to our new regions table. So we want to have the same field data on both sides of the relationship. And normally you're going to have at least one of those fields be a primary key. So that really kind of settles that we want to have region abbreviation be our primary key. So on the table design ribbon here, when I'm clicked into the region abbreviation row, I'll go ahead and click the primary key button. And then I'll go ahead and click Save. And I need to type in my table name. And this one is going to be regions. And I'll click OK to commit that change to the file. Step 4B gives us 8 rows that we need to create in our regions table. Let's go ahead and on the ribbon here, choose the button to change over to datasheet view so that we can type them in. I'm going to make these columns be a little bit wider just so that I can better read what I'm typing in. And I'm going to go ahead and save my change. This is one of the few things that you do need to manually save changes for because Access considers this actually editing the layout of the table. And then we'll start typing them in. We'll begin with FW, which is the region abbreviation for the far west. And I'm going to continue typing the rest of them in here. And we'll type in our 8th and final record here, region abbreviation SW, and the region name is Southwest. As soon as I go ahead and get out of that row, you can see the little pencil icon that's there right now goes away, and it's committed that change to the file. We'll go ahead and click X to close out the regions table now. For step 5, we're going to create relationships between two pairs of tables. For this, we'll go to the Database Tools ribbon and click on Relationships. And I'm going to select all 3 of my tables, and I'll drag them over to the grid. I could have also added them using this Add Tables pane. When I create relationships between tables, they're generally going to be between fields that are named either identically or very similarly to each other. Our first pair of relationships is going to be between regions and states. So if I take a look here, I can see that there's this region abbreviation field that is common to both of them. So that's going to be the one that I'll use for the relationship here. We're going to start off with the primary key side of things, kind of the parent version. That's the regions one. And I'm going to click on that field and drag with my mouse over to region abbreviation under states, and then I'll release the mouse. The instructions say that we are not supposed to enforce referential integrity, so I'm not going to make any changes in the Edit Relationships dialog box. I'll just go ahead and click create, and then we'll have this new line made. We also need to make a relationship between states and counties. So if we take a look here, we can see that state abbreviation is going to be our common field. It's actually part of a key in both, but it's the primary key in states and part of the composite key in counties. So I'm going to go ahead and make this relationship between the states side as the parent and then the county side as the related table. So I'm going to grab from state abbreviation over under states, and I'm going to drag over to state abbreviation under counties, and we'll let go over there. Again, we're going to not enforce referential integrity. We'll just go ahead and click create. We'll save our changes here, and then we can close out of the relationships window. In step 6, we're going to begin writing a series of queries. We'll start off with query 6a. I want to go back to the create ribbon here, and I'm going to go to query design. I'm going to close out of these two panes for right now, just so that they're out of the way. The instructions tell us that we're supposed to create a query to display information on each county. We want to list the county name, state name, region name, and number of residents. So we're going to have to find the tables that have those pieces of data in them. Well, I can guess that the county name is going to be in the counties table, and in fact it is. So I dragged over the counties table onto my grid here. I can figure that the state name is probably in the states table, and the region name is probably in the regions table. And it turns out those are correct. Remember that you can always go back and look at the instructions for a breakdown of each of the fields and a description of them for each of the tables. Just going to make counties a little bit taller so we don't have to scroll to be able to see everything. Make it a little bit wider as well. So I'm going to add the fields that are specified in the instructions. I can go ahead and drag them down to the grid, so I can drag county name from counties. We'll make that be our first field. But I can also just double click on them. So I'll double click on state name under the states table here, and region name under the regions table. The final field that I need is the number of residents, and that is back in the counties table. So we'll just double click on that there. The instructions say that we want to sort by county name in ascending order. So if I take a look at where I have my grid down below with the fields that are going to appear in my query, I'll see that there is this sort row, and under county name, I'm going to go and click on the little drop-down list and set it to be ascending. Let's go ahead and click save here. And we want to name this query query 6a because it appears in step 6a. I'm going to click OK. And then I'll click the run button here so we can look at the results. And it does appear that everything is being sorted by the county name. We have 3,144 rows or records, which matches what's in the hint. And we have 4 columns or 4 fields. So looks like we're in good shape with query 6a. Let's go ahead and continue on to query 6b. I'm going to close out of 6a. We'll go to the create ribbon again, and we'll click on query design. The instructions say that we're going to explore so-called bedroom counties, where many of the residents travel outside of the county for work. We want to create a new query listing the state name, county name, number of residents, and daytime population. So for the state name, I'm going to go ahead and add the states table to my query, and then we'll just double click on state name. For the other fields, we're going to add the counties table. And I'm going to expand this so we can see a little bit better. I want to add county name, residents, and daytime population. The instructions tell us that we only want to display records where the daytime population in the county is less than the number of residents, which means we're going to have to set a criteria. And the criteria is actually going to be comparing the values of 2 of our fields here, residents and daytime population. So I could theoretically set the criteria on either one of those fields. I'm just going to go ahead and choose to do it with daytime population, but the other way around would work okay, as long as I wrote my criteria properly. Under the daytime population field, the column down here, the criteria row, I'm going to say that I want to have it less than the value of the residence field. So inside of square brackets, I'm going to put residence. Those square brackets will tell Access that I'm looking at a field and I'm not trying to compare to, for example, text that says residence. The square brackets are going to be important here for us. We could also go into Builder and set up criteria in there, but just typing it in directly works. We want to sort by state name and then by county name, both in ascending order to finish things up. So under state name here, I'm going to sort by ascending order. And under county name, I'm also going to choose to sort by ascending order. When you're sorting on multiple fields, Access will go left to right. So since we want to sort on state name first, that needs to be the leftmost field. Let's go ahead and save this as query 6b. And then we'll go ahead and run it and look at our results. So we have our 4 fields again, and this time we have 2,165 records, which matches the number that the hint in the instructions says that we should have. So we'll go ahead and close out a query 6b. For query 6c, we're going to display information on small counties in plain states. We'll make another query in Design View, and we want to list the county name, state name, region name, number of residents, number of employed residents, and number of people working in the county. So for those fields, we're going to actually add all 3 of our tables. So I'm just held down the Shift key to select all of them as I went and clicked on things here. I'm going to drag all 3 tables over to the top part of my query, and then we'll just go and populate the grid down below. So we'll double click on county name, double click on state name, region name, number of residents, number of employed residents, and number of people working in the county. We have a criteria here as well, and this one's actually going to have 2 parts to it. We only want to display records for counties that are in the Plains region that have fewer than 10,000 residents. So we need both of those conditions to be true. It's in the Plains region and the population is less than 10,000 in order for that record to be shown. So we're going to set up our criteria to be an AND criteria, where we have all of our criteria for it on the same row down at the bottom of the grid. Under region name, we'll go ahead and type in Plains, and I'm just putting it inside of double quotes. It's a string or a piece of text that we're trying to match, so it does need to be inside double quotes. In this case, if I actually just typed in Plains without the double quotes, Access would automatically add them. The other thing that we're going to do here is put a criteria on our residence field. And we want to have this be less than 10,000. Make sure when you type in a number that you don't put in any commas. Decimal points are okay if you are dealing with decimals, but don't use any commas to try to nicely format things. Just put the whole numbers there. Let's go ahead and save our query here. We don't need to sort on this one. This one's going to be query 6C, and we'll run it. And we end up with 299 records, and we have 1, 2, 3, 4, 5, 6 fields. So we match what's expected from the instructions. Let's go ahead and close out a query 6C, and we'll continue on to 6D. We'll go back to the Create ribbon and click on Query Design again. For this query, we're going to calculate the percentage of residents in each county who are employed. Our query should list the state name, so let's go ahead and add the states table, and we'll grab the state name field for there. And the county name, number of residents, and number of employed residents. And all 3 of those are in the counties table. So we'll go ahead and drag over the counties table and grab county name, residents, and employed residents. We also want to have a calculate field that's going to display the percentage of residents who are employed. For that calculate field, I want to go to a blank column. And I could actually go and type in my formula here, but I'm going to use the Builder tool for this. So I'm clicking the blank column. I'll go ahead on the Query Design ribbon and click on Builder. Whenever we have a calculate field, we want to make sure that we give it a descriptive name. That way, if somebody's looking at that value, they know what it's actually supposed to represent. So if we're trying to keep track of the percentage of residents who are employed, something like percentage employed would be a good name for our field. So let's go with that. And after we have the name for our field, we want to put a colon, and then we're going to put the formula that will be used to calculate the value that's going to be displayed there. The instructions tell us that we're supposed to do some division. We're going to have the employee residence field from the counties table. We're going to divide that by the residence field from the counties table. Let's go ahead and select the fields actually using the tools here in Expression Builder. If we go under our database, we can expand that out. We can expand out the tables and then click on the counties table. And we can see the names of each of the different fields that are in that table. I'm going to grab employed residence and click on it here. And if I actually double click on it, it's going to add it to the formula here. So we have the name of our table and then exclamation point and then the name of the field. I want to divide that by the number of residents. So at the end of the expression that's there right now, I'm going to type in a slash for divide, and then I'll double click on residents. And it's going to go ahead and add residents. Now, this little EXPR part that Expression Builder put there on its own, that's normally basically a placeholder for where you would have a mathematical operator, like a divide or a multiply. In this case, there is nothing that should go there, so I'm just going to double click on it to select it, and then I can just hit the backspace key on my keyboard to go ahead and get rid of that. Go ahead and click OK, and then we can see that we have our field down here. Let's go ahead and save this query. This one's going to be query 6D, and we'll click OK. And we're going to run it. You can see that we have the fields that we want, but right now we can't actually see the value that's in the percentage employed field because it wasn't wide enough. See, there's a whole lot of numbers after the decimal point. We want to format that down. The instructions say that we want to format that as a percentage with 1 decimal place. So let's go back into Design View, and we can just do that using the button here on the Home ribbon. And when I'm clicked in that percentage employed field, I'm going to right click and go to Properties. Under the Format section, I'm going to choose to format this as a %, and I'm going to do 1 decimal place. One thing that you'll find as you're working with calculate fields is that sometimes you won't have the ability to specify the number of decimal places until you actually run your query first. So it's a good practice just to go ahead and run your query and then apply any formatting that you need for your calculate fields. Let's go ahead and run our query now, and we can see things are nicely formatted as percents with just 1 decimal place. There isn't any sorting that we need to have for this field, so let's go ahead and just save things, and then we can close out a query 6D. For query 6E, we want to explore the counties that have to import workers from other locations to fill all their jobs. We'll start off by going to the Create ribbon and creating a new query in Design View. We need to list the county name as our first field, so I'm going to add the counties table for that, and then I'll double click on county name to add it to the grid. We want the state name, so I'm going to add the states table, and we'll double click on state name. And then we also want to have the number of people working in the county and the number of employed residents, and those are both from back in the counties table. So we'll go ahead and add those fields. We also need a calculate field to find the percentage of people who are working in the county who are from the county. So I'm going to click in a blank field here, and we'll go up to Builder on the Query Design ribbon. Let's call this field percentage of workers from county, and then we'll put a colon. And the instructions give us the formula to use, which is the employed residence field from the counties table divided by the people working in county field from the counties table. So we'll go ahead and expand out our view of the database. We'll go down to tables and counties. I'm going to double click to add employed residents, and then I'll type in a slash, and we'll go ahead and double click again, this time on people working in county. I'm going to make sure that I get rid of that EXPR part because we don't have an expression or operator that's going to go there. So I selected it, we'll hit backspace on the keyboard, and we'll go ahead and click OK. Instructions tell us that we only want to display records where less than 80% of the county's workforce needs can be met by people living in the county. So we're going to set that criteria on the new calculated field that we just created. I'm going to go ahead and click down in the criteria row for that calculated field, and we're going to do less than 0.8. 0.8 is basically the decimal representation of 80% because 1.0 is 100%. Let's go ahead and run our query. You can see that we have our 5 fields and we have 136 records as given in the instructions. We do need to go ahead and format that percentage of workers from county field so it actually looks like a percentage. So we'll go back over to design view. I'm going to right click in the calculate field and go to properties. And we're going to set this as a percent. And we're supposed to have 1 decimal place per the instructions. After I make those changes, I'm going to go ahead and run it again. Looks good now. So let's save this as query 6E and we'll close out of it. Query 6F wants us to find the number of people who are residing and working in each state. Let's go ahead and create a new query in design view. And the instructions say that for each state name, we want to find the sum of residents, sum of employed residents, and sum of people working in its counties. So I'm going to go ahead and add the states table because that's where state name is going to come from. Go ahead and double click to add state name to our grid down below. And then the other fields are all in the counties table. So I'm going to go ahead and add that to the query as well. We want to add residents, employed residents, and people working in county. Now, in order to go through and find the sum of each of these values for each state, we're going to have to make this be a totals query. So in the query design ribbon, I'm going to click the button here that says totals, which will add this total row. Since we want values for each state, we want to group by the state name. But for these other fields, I'm going to go and choose group by, open up its drop-down list, and then change it to be sum. That way, for each state name, it's going to group by the state name, and then it'll calculate the sum of all the values for each of the counties within that state for residents, employed residents, and people who are working in county. Let's go ahead and run this query and take a look at our results. So we have each of our state names, but then we have each of those sums as well. The instructions tell us that we want to format the sums as standard type numbers with no decimal places. So I'm going to head back into design view. I'm going to close this add tables pane to get out of the way. And then I'm going to go to the properties for each of these fields that we're summing. So I'm just going to right click in the first one, go to properties, and I'm going to choose this as a standard type number with 0 decimal places. And we'll just click in the next field, do the same thing. And then our final one here, people working in county. So standard with 0 decimal places will basically give us the numbers with commas so that they're a little bit more readable. And then it turns off any decimal places since we're just dealing with whole numbers here. We have 51 records and we have our 4 fields as given in the instructions. So let's save this as query 6F. And we'll close out of it. For our final query, 6G, the instructions give us a SQL or SQL query that we're going to use. Let's go ahead and look at the instructions. And here you can see the query in the Courier font. It's what starts with the keyword select and ends with the semicolon. We just want to go ahead and highlight that, and then we'll right click and copy it to the clipboard. Back in Access, we'll go to the Create ribbon and click on the button under Queries to create a new SQL query. That query will likely have text that just says select semicolon. Go ahead and delete that. It's because we're going to paste in the entire query ourselves. You can go ahead and right click and choose to paste. You may get a message asking you if you want to allow access to access the clipboard. If you do, go ahead and click to allow. It just depends on which version of Access you're using because they have some different editors for SQL. And if you've already previously allowed it to paste things from the clipboard. Once you go ahead and paste, you'll see the text that we copied over from the instructions. Depending on the version of the SQL editor that your version of Access is using, it may appear slightly different. It may not have these colors going through and highlighting certain aspects of them. What's going on with this query here is it has multiple parts. We're starting off with the select statement, which specifies which fields we want to include in the query. So like we're grabbing the state name field from the states table, county name from counties. We're also doing this calculate field that we're going to store as daytime growth when we display the results. That's just daytime population minus residents. The from clause specifies the tables that the data is going to come from. So it's going to come from the states table, and then we're doing an inner join using our relationship to the counties table to go ahead and pull in data from counties. And this on part says that it wants to match things up between states and counties where the state abbreviation field in both sides is equal. The where clause is a criteria. It's only going to include counties where the number of residents is at least 750,000. And then we're going to sort the results by our calculate field in descending order. So I'm going to go ahead and run the query. And you should see here 87 records. And we're going to have 6 fields based off of what was specified in the select statement or select clause of our query. Let's go ahead and save things, and we want to call this query 6G. So with this query here, that daytime growth column is going to tell us basically how many people are traveling into that county during the daytime compared to how many people who are actually living in the county. So we can see that New York County in New York, which is Manhattan, has over 1.3 million people who are traveling into that county during the daytime to work in it, because there's only 861,000 residents who are employed, but there's almost 2.2 million people working in the county. Let's go ahead and close out of this query as well. Now that all of our queries are done, let's create an analysis questions table so that we can store our responses to those questions. I'm going to go to the Create ribbon, and we'll click on Table Design. The instructions tell us that there are 2 fields we need to have. The first one is going to be question step, and this one's just going to be the step number that we're trying to respond to, so like 8A. Since that's really short, with the text that we're going to have to type in, the short text type is appropriate. Each of the step numbers is also unique. There's only one 8A and one 8B, so this is going to be a good primary key for us. So I'll go ahead and click the button for primary key when I'm in that question step row. We need to have another field called response to store our answer for that question. The short text type is only allowed to store up to 255 characters, and for some answers, that might not be long enough. So what we want to do is change our data type. Instead of short text, we're going to go with long text, which will allow us to type in up to about 65,000 characters. Once we have that set, we want to go ahead and save our table, and we're going to call this analysis questions, and we'll click OK. Let's flip over to datasheet view by clicking the button here on the table design ribbon. And then I'm just going to go and make these fields be a little bit wider and a bit taller so that we'll be able to better see our answers as we type them in. I'm going to go ahead and save the change here as well, just so that I don't get prompted about if I want to change the layout of the table when I go to close it. Now we're ready to start taking a look at the analysis questions. We'll start off with question 8A, which asks, what might the percentage of residents who are employed in a state say about its economy? My answer here is that a state that has a better economy is likely to have more of its people working. If there are more people who are not working, it could be that they either can't find a job, or the costs associated with working, so like travel and things like childcare, stuff like that, might make it that it just isn't really economical to work. You do also have some cases where the population of a state either tends to be unusually young or unusually old, where you have more people who are outside of their working years. So they're just not going to be employed because they're either retired or they're still children. Analysis question 8B says, considering that commuting costs time and money, why might someone choose to live in a different county than where they work? And we're asked to name at least 2 reasons. For my response, I actually gave 3 reasons. First, you can have differences with housing cost. It might be a lot cheaper to be able to buy housing if you live a little bit further away. This is common in a lot of metro areas, like DC, for example, where a lot of people will commute in from eastern panhandle of West Virginia, even though it's a substantial commute, just because the housing is that much cheaper. You have some cases where the county line is actually kind of near the city itself that people might be commuting to. So just going across the county line isn't that far. If you're commuting to Morgantown, you can be in Greene County, Pennsylvania, in about 7 miles from Morgantown. Marion County and Preston County aren't that far either. So it may not actually really be all that far even if you are in a different county. Finally, sometimes you'll have couples where different partners will work in different cities and they might choose to live someplace that's sort of halfway between the two. For analysis question 8C, we're going to look at independent cities in Virginia, which are kind of unusual because they're not considered to be part of a county, even if they serve as the seat of that county. So, for example, Winchester is the seat of Frederick County, Virginia, but it's not actually part of Frederick County. Many Virginia cities are only able to fill a relatively low percentage of jobs with its city residents, and the question asks, why might this be the case? My response here is that, generally speaking, it's going to be county seats and other larger cities that tend to have a lot of the jobs in an area. Oftentimes, you'll have jobs connected to government, retail, things like that, that might go and need workers to fill them. But there's a lot of people who don't want to live in a city. They want to live in a more suburban or more rural environment. So those people might want to try to find that housing, but it's not available in the city limits. They live in the surrounding county that's technically different than the city. In most states, the county and the city would be in the same place, so it wouldn't look like you were crossing a county line. But in Virginia, since independent cities are not part of a county, the census treats them effectively like they were their own separate county. It looks like you're crossing county line when you go from the surrounding county into an independent city in Virginia. Question 8D says that the number of people living and working in the same county varies from 68.6% in the Mideast region, which is New York, Pennsylvania, New Jersey, Delaware, Maryland, and DC, up to 85.5% in the Far West region, which is Washington State, Oregon, California, Nevada, Alaska, and Hawaii. And we're asked what might explain the difference in commuting patterns between the two regions. My answer for this one is that it really boils down to geography and the size of counties. In the older parts of the country, which would be the Mideast region as a primary example, most of the counties tend to be relatively small. It's very common for metro areas around larger cities to go and span multiple counties. So even if you're commuting within the same metro area, there's a good chance that you might live in a different county than where you work just because there's multiple counties involved in the metro area where the jobs are. Out west, though, counties can often be enormous. It is relatively uncommon for metro areas out there to encompass more than one county. In all likelihood, even if you're commuting to the other side of the metro area, it's probably still in the same county as where you started off. Our last analysis question is question 8E. It tells us to look at the daytime population changes for the largest counties, and we're asked if there's any patterns that we can discern about which counties have negative versus positive changes, and why that might be the case. Query 6G, the one that we had the SQL statement for, takes a look at counties that had at least 750,000 people, and it tells us what the daytime growth was. If we go and take a look at the counties here that are sorted in order by their daytime growth, we see that the ones that have lots of growth, they're big cities. We have Manhattan in New York, Atlanta, Dallas, Houston, Boston, Orlando, Seattle, Minneapolis, San Francisco. If we go and take a look at the places that have negative daytime growth, so people are leaving there during the daytime, we have places like the Bronx, we have Brooklyn, we have Queens, we have suburban areas here, Prince George's County outside of DC. Basically, We see growth as being a positive where the jobs are in the urban centers that people are moving to. And the negative side is coming from the suburbs where the people live at night, but they have to leave in the daytime for their jobs. So let's go ahead and write that up. And for my response here, basically just said that the counties with large positive daytime gains tend to have urban centers because the jobs are there and that's where people are going to work. The ones that have the negative changes are the suburban areas that people live in, but they're not working in. They go back there at night. Let's go ahead and click out to finish saving our changes for that record, and then we'll close the analysis questions table. Since I had resized the cells a little bit earlier so that I could see the text better, it's asking me if I want to save changes to the layout of the table, and I'll tell it yes. The final thing that we want to do in Access is to try to run the compact and repair database utility. This is on the Database Tools ribbon, and it's this button up here on the left. Just go ahead and click on it. Ideally, everything runs really quickly and it just comes back to the same screen you were at before. Occasionally, you might get a message that the file was in use and it couldn't do compact and repair. If that happens, it's not a huge deal. A lot of times, antivirus software or cloud syncing might cause problems that will lead to that sort of issue come up. Don't worry about if it happens, but do try to run compact and repair. It can go and make your databases smaller, especially if you've deleted and recreated records. Make it a little bit easier when you go to upload things. That completes our project. If this was your actual homework, you would be ready to submit now. Since this is a homework help project, though, please do not turn in your file. If you need more help with completing Homework 3, the CS 101 and Lane Department Learning Centers are available to assist you. You can also email your section instructor for help. Thanks for watching, and have a great day.